Okay. Good evening, everyone. This is Pranay Karzavkar. First of all, thank you very much for joining this webinar on digitalization of transformers. And I would like to wish you all happy Diwali. And so this webinar is regarding the digitalization of transformers, of distribution power transformers, which is a main capital item or the critical item in a power system. And it's very important to monitor and keep this transformer healthy, because since it's the heart of the power system, it has to be kept healthy. So for that, we need to monitor this transformers, and it's the solution which we are providing. So let me introduce myself. This is Pranay Karzavkar. I am in KRYFS since last 11 years. I completed my diploma in electrical engineering. I've started my career with KRYFS Power Components Limited as a sales and marketing and operational team. Now it's again the opportunity to be a part of this KRYFS Technologies Geo division, which is into digitalization of transformers. Along with me is my colleague, Mr. Mubarak Khan. He is the SBU head of our KRYFS Technologies company, and which is a part of KRYFS Power Components Limited. So thank you very much. So let me start with the webinar. I guess all there are major participants who have already logged in. So we'll start the presentation. So during this presentation, we are going to cover these points. It's the introduction, the problems we are facing the power system, the solution KRYFS Technologies is going to provide, what we are going to do, the product variants, the case studies on which we have installed our BOLA, our transformer system, the installation examples, the testing and certifications which we have done on the device, and the brands who trust us, and even the conclusions with your question and answers. So KRYFS Technologies is a part of KRYFS Power Components Limited. We are having the mission to reduce the failure rates of electrical transformers in India and make it better than global standards. Thus, this will help to make the nations increase the asset reliability and reduce the operational cost. Even we are having our values, like what I mentioned, is the honesty, humility in dealing with people's, humanitarian approach, the helpful nature within the company and also our companies, and the hard work, happy outlook, and Hamesha Kaizen. That means it's always improvement. So KRYFS Technologies, like what I informed you, like KRYFS Technologies is a part of KRYFS Power Components Limited, which was founded in 1992. We are having overall 3,000 plus satisfied customers within our different umbrellas, and we are having total about 750 happy employees. We are having our presence in about 40 globally countries, and we are having total 9 manufacturing facilities in pan-India. So KRYFS is the only manufacturing company who is approved for manufacturing transformer core lamination and transformer tanks up to 765 kV class, which is approved by TGCI. And apart from this, even Toyota Tsusho, they have in Toyota Tsusho, that is a car manufacturing company from Japan. They have invested 20% stake in our company. So not only they have invested the stake in the company, also they have increased that stake in 2013. So under KRYFS, we are having like seven verticals. Like we are into the KRYFS Power Components Limited is into manufacturing of core lamination, supplying of core lamination for transformer industries, even supplying of transformers for various utilities and industries. And also we are supplying transformer tanks for various top transformer manufacturing companies. Even we are into manufacturing. KRYFS Transformers Private Limited is into manufacturing of small distribution transformers up to 200 kVA. And even like KRYFS Technologies is into digitalization of transformers industry. Even we are into ringing solutions, which are used to lift the heavy equipment. Those are webbing sling sets. Those are the companies we are doing. Even we are doing EPC projects for Pan India to establish 33/11 kV substations in Pan India. Even we are into solar rooftops. So I would like to request Mr. Mubarak Khan to address the problems which all the industries are facing.
So hello everyone, my name is Mubarak Khan. Thank you for joining in, and thank you Pranay for giving the small introduction and making the pitch for what we are going to talk about. So we'll start with the problem we are addressing. What is the problem? Actually, distribution transformer failure rate in India, if you know, it is in the range of 15 to 20% compared to the failure rate in developed countries, which is 1 to 2%. In India also, the private utilities, the failure rate is less than 5% actually, but in the government utilities, it is much more. If you see some very top utilities in India, they even have a failure rate of 0.5% or 1%. But that is not the case everywhere. What point we want to make here is that it's not that it is impossible to have a low failure rate in India, because many of the good utilities have created an example. So what we want to do is we want to reduce the failure rate from this 15% which is going on currently to less than 1% or 2%, whatever is best possible in the course of time. In India, there are around 4.24 million distribution transformers. In total, 62 distribution utilities across in India, and it is expected to grow by 8%. So number of transformers are also going to increase, and similarly the loss which is happening because of the transformer failure is also growing. So what we need to do is, like, as we are adding new transformers in the fleet, we need to add more good and smart transformers so that we reduce the failure rate. It is estimated that India is losing minimum 636 crore per annum due to the transformer failures, only the distribution transformer failures. This is excluding the revenue loss during the shutdown and repair time. It is only the cost of the asset. What is the problem? Going more deep into what is happening, transformers are most critical and expensive assets in electrical transmission and distribution network. Failure of transformer may lead to loss of life, property, and sometimes such incidents may be very catastrophic. Transformers require proper care and maintenance, or it will definitely fail like any other asset. There are many reasons of transformer failure. We will focus on which are the ones which have high probability of occurrence and high severity of consequences. Different type of issues related to transformer are: not taking proper care involves 3 types of risks for the transformer. These risks will definitely cost you a lot of revenue in short as well as in long term. The revenue which is being lost in a transformer can be categorized in 3 forms. One is the transformer getting damaged and accidents happening in the transformer, means some blast or some short circuit flash, the transformer getting completely damaged. Or second, revenue loss can be through reduced service life. So if the transformer has supposed to run for 25 years, it will run only for 5 years. Third is the low operational efficiency. Okay. Talking about transformer accidents and damage, transformers are often placed at remote locations, and there is a risk of oil leakage and theft. This is one of the major problems for major utilities in India, Africa, etc. There is a high chance that rapid temperature rise of the transformer can cause insulation failure, partial discharge, or overloading. And catastrophe can happen before you can take a corrective action. Because of unfavorable operating conditions, moisture in oil may increase, leading to loss of oil BDV and thus leading to transformer damage. Poor quality of installation, poor quality or installation errors may lead to failure, but the user will get to know only after the transformer has already got damaged. This was about the accidents. Then secondly, the reduced service life. In general, transformers are designed for a service life of 25 to 30 years. This guaranteed service life will achieve only for the transformers operating in ideal condition. Some of the utilities have even suggested that after 15-20 years it should get decommissioned because the transformers, old transformers get failed very fast. But actually that is not the solution to change too early, right? If the manufacturer can design a transformer well for, so it should be in that way. Usually the service life of the transformer is governed by the service life of cellulose paper. The cellulose paper has chances of degradation under the influence of moisture, temperature and ambient air. If the transformers are operated in good condition with timely filtration, the only enemy remains is the hotspot. If it is managed, the full service life of a transformer can be achieved or even increased. Hotspot formation can be avoided by optimally loading the transformer, balancing the load, especially between the phases, and other best practices followed in the industry. Low operating efficiency. Optimal loading is key to achieve efficiency of the transformer, as too high or too low load can lead to high losses, which in turn negatively impact the efficiency. Often bad design leads to bad efficiency performance. A proper monitoring to prove the same can help in further negotiation with the manufacturer for better product. Efficiency is directly related to money, and the transformer operating with low efficiency is a direct loss of revenue. So talking about the problem a lot will not solve. So we need to work on what are the solutions. Often there are two main aspects of the solution which we can go for. First is the procurement. You need to procure proper good quality equipment, selection of the vendors, and the selection of the vendors is very important. Second part is the operation and maintenance of the transformer. Often many of the transformers fail within the first 5 years. That can be because of the manufacturing defects, but after that, because of improper maintenance, the transformers fail too early. The solution can be good and continuous monitoring of critical parameters of the transformer. If we have this one, what happens is when we have a transformer, if it is a new or an old one, if there is a manufacturing defect in a new transformer, because of continuous monitoring, you will definitely get to know in the initial period only. Okay? Then getting timely alerts and notification for the abnormalities. Prompt corrective action, timely repairs based on alerts and notification. These three steps are there which can help you do a proactive maintenance. Okay? Then we have a routine scheduled maintenance and routine testing of a transformer which is planned, and it needs to be done in real time. So there are many parameters which can be covered in the transformer online monitoring, but not everything cannot be covered. So that is why the normal offline testing needs to be done in time. Then lastly and most importantly, procure purchase of good quality transformers followed by correct installation and commissioning. Okay, so what we have to offer, we cannot solve all the aspects of the problem definitely, but we can at least offer a certain portion which will help you maintain the asset properly. So introducing BOLA TMU transformer monitoring solution. BOLA stands for Better Operations and Life by Analytics. It is an indigenously developed IoT-based online transformer condition monitoring system which can take data from various sensors installed on the transformer, process the data on a cloud-based software, and present data on a user-friendly dashboard along with useful insights about transformer's overall health. BOLA will also send alerts and notification on SMS and email Whenever there is any abnormality sensed, this allows maintenance to be scheduled and corrective action can be taken before the failure actually happens. System overview. It is a very simple system layout where we have shown that various sensors are installed on the transformer which are connected physically to the BOLA transformer monitoring system. These sensors can be temperature, pressure or level and all. It can be analog or digital output may be present. The sensors are connected on the BOLA monitoring system which has a GSM port which transmits the data to the cloud. On cloud, we do the data processing through it is stored in a database. Data modeling and data analytics is being done, and the data is displayed on a user-friendly dashboard. The device is also having a facility to show the notifications via SMS and email. If we talk about which parameters can be covered, normally we can cover any and all parameters of the transformer, but just to mention, we have oil temperature, oil level, winding temperature, voltage and current, energy, power, harmonics, etc. Additionally, we can have lug temperature monitoring, tap position indicator, moisture in oil, energy efficiency, production relay status, Buchholz PRV status, OTI, WTI, and any other customized parameter. Even we can offer control of cooling fan, control of cooling pump motor, or any other control function which can be required. Local enunciation, etc. is also available. If you want anything else, we can definitely integrate that. Okay. It is or theft protection. This is an optional feature. If somebody requires GPS tracking theft protection, we can offer that. And then we have power backup facility also available within the device. That is also optional. Okay, so coming to the data which is going to the cloud, data management basically is done in the backend software which is running on Node.js. Then we are having our SQL database where we save all the algorithms and the analysis which is being done. The same data is shared on the front end dashboard and the mobile application. The whole system of the software is on the Amazon cloud server, which is a highly secured server, and it is also secured through multiple layers of encryption and cybersecurity protocols. So your data is safe in the cloud. There is very minimal chances that it can be breached somehow. The technologies we are incorporating in this device, which is looking quite simple. So the technologies are like IoT technology used for monitoring of critical parameters of transformers on remote PC. Edge computing enables real-time alerts and notification. AI and ML empowered algorithms give advanced and diagnostic analytics. Digital twin of the transformer is created online. Cybersecurity and data privacy ensures the data is safe and secure. Benefits of using such a system is, first of all, the main thing, prevention of the accidents, then operational life extension, okay, that is mentioned, reduced operational expenses, enhanced safety and reliability, and KRYFS excellent customer service assurance. This is a small snapshot of the BOLA dashboard. As you can see on the front end summary, there is a whole summary of the complete transformer fleet. Then we have individual parameters displayed in the form of numbers, values, as well as graph. There are certain parameters which are displayed directly, and there are certain parameters which are derived parameters, which normally you will not do. They are shown through calculation. Okay, like here we measure the load and we give you the load percentage based on the 100% capacity. Okay, so there are various trends and analysis available. I'm not showing all, just representation. There is also one very good feature of the map notification, which we can see, where all the transformer fleet is displayed on the map along with the location. It can be zoomed in to have a very close view. If you hover your mouse on a particular transformer, actually it will display the important parameters of that particular transformer and the alert which is being generated on that. Transformer are color coded, so black one represents the transformers which are offline, green represents the transformer which is healthy, and red represents the transformer which is having an alert. Okay. So this was about the technology which we are using. So now coming to the product variant, different product varieties what we offer. So we have segregated the product based on transformer size. For transformers up to 500 kVA, the important point to consider is the transformer has very limited number of sensors installed. Actually, there are no such sensors. All physical visual indications are present, but sensor transmitters are not available. Cost is a very important factor as the transformers are very small and are of very low cost. So here what we offer is that we offer basic parameters like oil temperature, oil level and winding temperature can be shown as calculated value. If the energy meter installed, we can have the voltage, current, energy and power factor, harmonics, etc. Okay. So the model offered for transformers up to 500 kVA is BOLA P16, which will include oil level sensor, temperature sensor and some accessories. Okay. Data visualization, software, etc. comes along with the product. If on site, there should be energy meter already with CTs already installed. If it is not installed, then we can provide the energy meter and CTs at an additional cost. Or we can skip that monitoring also if we want. Second model, what we offer is from transformers from 500 kVA to 5 MVA. In such type of transformers, the sensors are already installed. Many of the sensors are installed on the transformer. Transformer is a medium expensive asset and monitoring is very essential. Cost implication for monitoring will be minimal. In such kind of transformer, normally all other parameters are same as before, but we additionally monitor PRV, Buchholz and other production relay status. Okay. Again, the model is BOLA P22 for this size of transformers, and all other parameters are same. The only difference is that one relay board will be added extra in the complete BOLA offering. Okay. System requirement, energy meter, CTs and production relays shall be already present there. If it is not present, then we will replace it at an additional cost. Coming to transformers above 5 MVA, important point to consider is that transformers have sensors and production relays already installed. It is an expensive asset, and definitely the cost of monitoring here is very minimal as compared to any other transformer size. Here we can have oil temperature monitoring and winding temperature monitoring through OTI, WTI directly, which makes it more accurate and suitable for this type of application. The model offered is BOLA P. Sorry, this is a mistake. The model offered is BOLA P35, and additionally here we have OTI with communication and WTI with communication. Models. So now this was the three varieties of BOLA, and there are a lot of customizations all around. But we have identified some of the customizations which are common requests from the customers. So that is mentioned here. If you want a physical hooter on site, then that hooter can be provided. If you want cooling fan control or cooling pump control or any other control function, that is available at additional cost. OLTC temp position indicator with analog output, that one is also available at an additional cost. Then we can also offer moisture monitoring, okay, and lug temperature monitoring of the LV terminals. These are also two customizations which are available. If you have any other customization, any other request, any other parameters which you need to be monitored, it is available. We need to discuss the application and we can do that. Okay. So coming to case studies, so I will hand over the mic to Mr. Pranay, who will discuss the case studies of this solution. Thank you very much.
Yeah, thank you very much for giving the brief idea about the BOLA device, which is a monitoring of transformers. So let me inform you that we have already installed within this span of 2 years, we have already installed about more than 100 numbers of devices pan India. and we have already installed this in some of the industries and electricity boards. And we have found some of the case studies which will definitely help, which has already helped the customers to prevent the transformer failure. And even they are able to get the proactive monitoring. Because of the proactive monitoring, they are able to help the transformer being getting failed. So we have just want to discuss about, just want to present you the case studies which we have done on some of the private industries as well as with some of the utilities. So first case study which we did on one of the industry, that is Vision Industries. The make of the transformer was Kirloskar Electric Company, and the rating of the transformer was 750 kVA. So at one time, what happened? The transformer RF phase to neutral was increased. Suddenly, it went to 287 volts, and it was indicated in our dashboard. And evenly, this abnormality was the indication was given to the end to the maintenance person. And with this sensor, the indication was in the form of email notification as well as on an SMS alert was given to the maintenance person. Upon the receipt of this alert, the maintenance person immediately went to isolate the transformer from the power system. And you can see from the graphical representation of our dashboard, it shows the voltage being increased from between R phase to the neutral was 287 volts. So the end customer, the Vision Industries, they send this transformers to a factory, or a transformer factory, to rectify the problem which they have because of this the voltage increase in the voltage. There was some damage in the transformer. So then send this transformer to factory. So what we investigated that the R phase, between the R phase was there was a flashover, because of which the windings get shorted, and it was already damaged the insulation property of the transformer of the winding. Even we did the root cause analysis with we rectified the problem of the transformer, and we have found the possible reason, what could have the possible reason for the failure of the transformer. So it is basically due to the hotspot temperature, because of the the short circuit occurred between the puncture occurred within the insulation of the transformer. There was a hotspot temperature occurred, and it was for a longer period of time, and the moisture oil may have caused when the dielectric strength of the oil and weaken the insulation of the winding, and it leads to rupture of the winding insulations during even normal voltage condition. So what remedial actions also we have done, like the customer maintenance team could have disconnected transformer on time before any major damage could have happened on the transformer. And although the customer paid 1.5 lakhs to repair, and rupees 10,000 per day, the charges for a rental of an old transformer on the factory. And this could have been worst if this could have not been detected proactively by our BOLA device. And it could have damaged the transformer more, and even might they have to replace it with a new one. Also, it could have been attracted more cost toward the rental of the transformer, and manufacturing. Even for manufacturing new transformer, it may took around 8 weeks to manufacture new transformer. So because of this proactive monitoring, they have reduced the operational cost and repairing cost of the transformer. So we rectified this transformer at our factory. At our transformer factory, and after rectification, you can see the normal working condition of the transformer, which can be shown on our dashboard snapshot. The second case study which we did on one of the transformer, on a small transformer which is a rating of 63 kVA, and the customer was APC-PDCL electricity board. So we installed this device on a small rating transformer. So during the time of November 2020, the oil temperature of the transformer was showing continuously high, and the oil temperature the rise in the oil temperature, you can see from the graphical representation of our dashboard, the maximum it went to 72.1 degrees Celsius. And you can see the average and minimum the temperature of the oil temperature. So this alert was given to the junior engineer, and immediately it was sent through via BOLA device in the form of email notification as well as SMS alert. Even the second graphical representation shows that the loading of the transformer was around 158%. This is a very the actual reason for the failure of the transformer. Even in the utilities, they are not able to monitor the actual load of the transformer, but by installing of a device, of our transformer monitoring device, they were able to see the performance. They were able to see the load percent of the transformer. So on that time, the loading percentage, maximum load percentage went to 158%. Even in the ampere graphical representation, you can see it went above the threshold value. So being a transformer company, we suggested them to keep the transformer on a normal load of around 70 to 80%, and thanks to the APCPDCL that they maintain the transformer from the next month maximum up to 68%. So you can see from the graphical representation of our BOLA dashboard, they maintain the transformer maximum up to 68%. Even because of this, the oil temperature was not actually, it should be around 72%, but 72 degrees Celsius, but they maintained within the load percent of the transformer. So we suggested them some actions to take prevent actions. Not only our device indicated the abnormalities in transformer, but we also suggested them with some of the remedial actions to be taken. The major hazard is with the oil rise in the oil temperature is associated with the overloading of the transformer. Such rise in the oil temperature makes the transformer oil more hygroscopic, and it absorbs more moisture from the cellulose paper. This leads to rapid reduction in the oil BDV value, as well as the accelerated aging of the transformer. So with load and temperature maintenance within limits, we have reduced the aging rate of the transformer, well as avoid catastrophic failure, which may have occurred because of the drop in the oil BDV value. The third case study, which we found in our own factory, obviously we tested this device 3 years back on our own factory. So with this graphical dashboard representation, you can see there was a voltage variation on a particular phase, and this indications went to our maintenance team. So in this incident, there was sudden voltage drop on the LED terminal. The neutral voltage reduced to 50 volts, and the abnormalities was then detected by our transformer monitoring device, and the alerts went to our maintenance persons via SMS and email. Our maintenance team then physically visited the substations and observed. They observed that there was a humming sound emerging from the transformer. And our team immediately isolated transformers from the power system. So after diagnosing the issue, what we found, our team found that the jumper connections between on the HV side there was loose connection within the jumper, and immediately they tightened the jumper connections and rectified the problem. And immediately they charged the transformer with the proper inputs, and obviously there was a normal operation of the transformer happened after rectification of those problems. So I would like to ask Mr. Mubarak to show the installation examples which we have installed our BOLA device on some of the transformers.
Okay, thank you very much, Pranay. So this is installation examples are just some images which I'm going to show, which represents how the system is going to be installed and give you a visual understanding of how it is going to be installed on site. So here you can see it is a large transformer and we have a substation out there, and we have installed the BOLA TCM on a independent stand, which is shown here near the transformer. Okay, and the wiring is done through a PVC conduit. Secondly, we can, this one is the majority of the applications, the system is installed in this way, where we find a wall nearby the transformer and we install the BOLA TCM there and we connect the wires on the sensors. If we have a nearby cabinet or if we need to install the system in the control room, that is also possible, which can be done in this way. Normally, it will be always good to have a BOLA TCM system installed in the new transformer. So we can collaborate with the OEMs and the OEM can make a special provision on the transformer itself to install the BOLA device. Okay. So these are the 3 installation examples which I have shown. There can be many depending on the site requirements. Okay. The BOLA system is type tested in all the electrical, mechanical, and other testing systems required. So it can easily be, we can easily participate in the tenders with all these test certificates. Okay. Brands who trusted, there are so many actually, but we have not included all the names here. But as you can see, Powerica, Filatex, South Bihar, Power Distribution, APCBDCL is also there, but it is not mentioned here. Tata Power, Welspun, Summer Diamond, Bharat Bijli, and all. Okay, so all these are the people where we already have installed. So conclusion, it is critical to monitor the distribution transformers in real time in order to enhance efficiency, reliability of the asset. Real-time monitoring will also ensure accident prevention and will avoid catastrophic failures. While there are many parameters which can be monitored, which are indicator of health of the transformer, but it is impractical to monitor everything, considering the comparative cost of monitoring versus cost of the asset. Monitoring the vital parameters give optimum balance between the real-time monitoring as they give first-hand information on abnormalities, and after detecting them, further investigation can be carried out on the asset. KRYFS Technologies provides reliable and cost-effective solution for monitoring a transformer, which can be easily implemented and utilized for prevention of transformer failure, enhancing the life of the asset and improving operational efficiency. With that, I would like to conclude this presentation. Thank you very much for your patience. We can have like it's time for question answers. So if you have any queries, questions, you can ask please.
So this is the one. There is one question.
First question is from Vilas Bhaskar. What will be the cost without sensors for 1 MVA TP? So Vilas, it's good that you have asked this question. I think we can take this question offline about the price. Commercials we can take later, it will be better. If you have any technical question or any doubt, we can do that. Yes, please. Can it connect with SCADA system? Very good, interesting question. Answer is simple, yes, we can connect to SCADA system. We have all the connection possibilities which are which may be required, like RS-485, IC-6250, fiber optic, or any other system requirement we can do. We can even have a IoT VPN which can be used for a local server within your premises. Which communication modes you support? As mentioned, we give all the different type of outputs which may be required for the SCADA system. RS-485, IC-6250, Ethernet, and all. How will you connect lug temperature? We have specially designed lug temperature monitor which can be used. If we can have an offline discussion, I can show you the sensor and we can have a demonstration about that. So we will connect the sensor on the lug directly. The sensor which we have designed is specially tested up to 1 kV, so it can easily be used on the LV terminations. And then we can do the lug monitoring. How about Profibus or Modbus, which generally used for SCADA? Yes, we can do. Mangesh Bakshi ji, we can do it on that, on those protocols. Vilas, does it require shutdown for integration of lug sensors? Definitely, it will require shutdown because we need to operate on the live system. So definitely shutdown will be required. Apova sir, thank you for joining, sir. Thank you for joining, sir. Thank you. Thank you.
Thank you.
Yes, sir, yes. So definitely, we are in touch with various discoms across, and things are moving forward ahead. I would request if you can support us in that direction or give some guidance, that will be great.
Mubarak, do you hear me?
Yes, sir. Yes, sir. I can hear you.
I should many thanks to you and your team for this wonderful session. And I learned that this is very much useful for the utility. That is the discom in our country. They are losing majority of the transformers, distribution transformer, due to such overload and information gap because of their vast jurisdiction. Every section officer will be having many tens of transformers, say 40, 50 of transformers in rural areas. He can't be in a position to visit each and everything. So it's a very good information for those people. The IoT and other IT platform provides such information well in advance. They can do it. Also, you told that it will be collaborated with manufacturer also. It's a good thing. Currently, from your webinar, what I understand is there are 3 parameters you are tracking: temperature, voltage, arms, for analyzing all the abnormalities. If possible, you provide additional parameters like surges, which are the main cause for the failure of transformers, especially rural areas, where lightning plays a major role. So if those are also possible, then we can surely drastically minimize the failure of transformers. Because overload is very much present in rural distribution. And a sudden overload, instead of analyzing the sudden overload for a few seconds, the duration, I square T, may also be taken into account so that they can have an immediate priority. Because the rural discom, they are aware that the transformer will get overloaded. Because of time and energy information gap, they take time. So surely your technology will be a tool or an aid information to the section level offices. I hope it will penetrate to the rural level also. Thank you, Khan.
Thank you, sir. Thank you very much. I think we can actually, we have not included in the presentation, but yes, I think we can take the input from the lightning counters actually, which can also give first-hand information on if there is a lightning surge which may have occurred in the line. That is a very good input we have got. And regarding the I2T, I'll have to check whether we can have such a kind of analysis with us. Thank you, sir.
Yes. That's what I wanted exactly. Because instead of merely mentioning 150%, that can be for few seconds. Because it cannot create a panic to the distribution engineers. There can be some timed overloading, say 120% for few minutes can be permissible. So it's not permissible actually, but it can be tolerated. They can't go and switch off every transformers, and by the time they go, the load will become very low because of rural abnormalities. This is my suggestion only. Thank you.
Thank you, sir. Thank you. Right, sir. You are right. Thank you. Okay, so one more question we have from Mr. Rohit Somani. Can any parameter be controlled? Can transformer be tripped? Yes, of course, definitely we can trip the transformer. We can control fans. We can control a hooter which can be there locally present. Or any other requirement, it can be done. No issues. Controlling is not an issue. We already have these control parameters which are available, which is programmable. So we can integrate them. Okay. PPT. This session is recorded, so I will upload the whole presentation on YouTube. So I'll share the link to all those who have registered. And if you don't have registered or you are coming through some reference, you can share your email IDs so that I can share the presentations, the recording and presentation with you. What is the next? How many years it lasts for? The service life of the device is 10 years, guaranteed service life. Definitely, it will not fail in that period, but that is the service life of any electronic component which is normally available. Thank you, sir. Vilas Bhaskar. If it will control the DT, then what's the difference in SCADA and BOLA? Very good question. What's the difference? See, the thing is that if we try to differentiate things on this way, definitely the same thing can be done through a PLC. The similar things can be done with SCADA. Similar thing can be done with any other IoT, custom-made IoT solution. That's not where we want to differentiate. The place where we differentiate is that we have designed this system specially for the transformer. So whatever things are there, whatever parameters, whatever facilities which are available in the BOLA are actually designed for the transformer. Internal software is designed for the transformer. Alert, notification, the dashboard, the software programming, everything. If you go for SCADA, definitely SCADA deployment integration cost is really very high, which is not the case in BOLA. So it becomes, because it is too customized, especially for transformer, the cost becomes really very less. That is what I can mention. The cost of the system overall, the cost to customer becomes really very less because it is a, we have customized once and giving it to everyone. I hope the question is answered, Vilas. Any other question?
So if you have any questions related, if any regarding the transformer monitoring solution and the solution which we are providing and the installations which we have done, I request you to send a mail or contact us on the details which I mentioned on the screen, and so that definitely we will answer your questions and your queries related to the transformer monitoring solution. We will like to reply as early as possible on. So there are one more questions coming on.